Hi everyone, just let me know if you can hear me. I think we should be live now. Hi everyone, just let me know if you can. You can just say yes if you can hear and see me clearly. See me clearly. Okay, great, great. So if you guys were there yesterday we had solved a very interesting question, right? And I had talked about the logic, and I had also given an idea that how to code it. I think the echo should not be there now. Is it okay now? The sound? Yeah, okay, great. Yeah, so yesterday was a great question, and I recommended you guys to code it before you sleep. So could you do that? How many of you went ahead to code yesterday's question? Okay, today's question is also very interesting, and I would say coincidentally it also falls into the same category. I mean the same kind of concept is used here as well. Did you guys get some time to read and understand the question? How many of you read the problem statement and understood what it says? Okay, Rajit is saying that he solved with brute force and got TLE. Okay, cool, but I'm happy that you at least tried doing something. I was only able to pass 37 out of some 50 test cases. Okay, that means the solution was wrong. Okay. Anyone else who tried something else and probably got the code accepted? Got TLE? Okay. It looks like many people who tried this question got TLE. N square will TLE naturally, isn't it? Because if your logic is n square, you can see that the value of n, if you're talking about the length of flower, it is 5 into 10 power 4. So if you're doing 10 power 8 iterations, more than 10 power 8 iterations, I mean mostly it should TLE. Yeah. Okay, I think for everyone's benefit, we will quickly read the problem statement. So the problem statement says that you are given a 0 index 2-dimensional integer array. So yeah, every array is 0 indexed as far as we are talking about standard languages. So we have a 2D array, and in, like you can see here, flowers, this is our 2D array or vector of vector, whatever you call. Here every entry denotes start comma end time of something. So you can imagine it like this, that there are different flowers, and for every flower there is a starting time and ending time. So for example, let's say there is a flower which blooms at 1 a.m. and maybe shrinks at 6 a.m. right? So this is the duration of that flower. So from 1 a.m. to 6 a.m. that flower is blooming. That is the duration. So that is exactly being told here, that start comma end means that ith flower will bloom from start time to end time inclusive. So inclusive means that when you talk about exactly 6 a.m. I can say yeah, it is still blooming. When you talk about exactly 1 a.m. I can say it's still blooming. Only before 1 and after 6 it won't be blooming. Okay, cool. So there are many such flowers, and for every flower you have start comma end time, right? Now you are also given another array, people. So people is another array, and in this array the ith element tells the arrival time of ith person. So let's say there is a person who arrives at 2 a.m. Now if this person arrives at 2 a.m., then will he be able to see this flower? The answer is yes, he will be able to see this flower. Why? Because 2 lies in between 1 to 6, correct? So what we have to do is, for every people I have to tell that how many flowers that person will be able to see. That's it. So let's say there are multiple flowers. There is another flower which blooms at 3 and shrinks at 5, and then there is another flower which blooms at 2 and shrinks at 9, and then there is another flower which blooms at 9 and shrinks at 12. And you have got different persons, like the first person's arrival time is 2, the second person's arrival time is 4, the next person's arrival time is 10, the next person's arrival time is 1. So for every person I have to say that how many flowers that person will be able to see. So how will the brute force approach look like? So a lot of you said that you were able to solve this question using brute force. So I think the brute force approach could be as simple as that. For every person, I can check whether his or her arrival time is lying within these intervals or not. For example, 2 lies in between 1 to 6. So this person will see this flower. But does 2 lie in this interval? No. Does 2 lie in this interval? Yes. Does 2 lie in this interval? No. So I can say that the first person will be able to see 2 flowers. Similarly, when you talk about second person, can you tell me how many flowers the second person will be able to see? Technically speaking, how many of these intervals contain 4 inside them? So I can say this, and this. So 3 flowers. So this person will be able to see three flowers. So I think the brute force approach will be super easy. For every person, all that I have to do is I have to scan this array of flowers, and all that I have to do is I have to check whether this element which denotes the arrival time lies in that range or not, and that way I'll have my job done, right? So what I can do is I can probably create a very simple answer vector, okay, and after that I'll iterate on all the persons one by one. So I am going to iterate from the beginning all the way till the end, which is people.size -1. And what I am going to do is, as I told you, for every person I have to scan all these intervals, means I have to scan all these flowers. So I'll be writing another nested for loop inside it, where I'll have a loop invariant j. It starts from 0, j smaller than flowers dot size, and j plus plus. Now all that I have to do is, my current person is ith person, okay, and for ith person I want to check these intervals, the inclusivity of these intervals. So what I'll do is, if the arrival time of my ith person, people of I, if it happens to be greater than equal to flowers j0. See, what is flowers j0? Flowers j0 is the blooming time of jth flower, because it has been told to you that you have been given a 2D array where the first element is start time and second element is end time. Similarly, I can say that people of I should be smaller than or equal to flowers of j1. Okay, so all that I have written, it logically means that the arrival time of this person should be greater than equal to the bloom time and smaller than equal to the shrink time, right? And if this is the case, then in this situation I can probably do a counter plus plus. And where should that counter be initialized? Outside. So I can declare a counter variable which is initially 0, and I can keep updating it inside this for loop. Now by the time this for loop is over, this count will denote the number of flowers which will be visible to ith person. Can I say that? Yes or no? The answer is yes. So what I can do is I can push it inside my answer. That's it. So I can just do we had int count over here, and yeah, I think everything looks clean. I hope I have not muddled up with anything. Yeah, so now here I can do answer dot push underscore back count, right? And then I hope finally we can just return this answer, and then the game is up, right? Let's run and see what happens. It works. Let's run on some other cases. Works, and let's submit. When you submit, most of you have submitted this solution, I know that, and you would have gotten TLE, right? Okay, why TLE? What is the time complexity of this solution? Let's analyze the time complexity. If let's say the number of people is m, and let's say the number of flowers is n, then the overall time complexity will be m multiplied by n because of this nested for loop, correct? And now we can see that both m and n are very large. M is also around 10 power 4 and n is also around that. So that is the reason you got TLE. Now we have to do something better. So how can we do something better? First, I'll scrap this code so that we can start thinking from some original point. Tell me one thing, if I ask you one very basic question. See, I know this question has multiple solutions, and if you go to this solution tab, you will be able to find all those solutions and everything. But I'll help you hone some original thinking. I'm not sure the solution that I am going to discuss is present there or not, but let me start by giving some basic hints. So Faizan is saying we can take two vectors. That's very interesting. Okay, we can store the flower in a map. Yeah, you can store wherever you want, but also give the logic behind it. If you want to use map, why do you want to use map? Okay, coming back to it, tell me one very simple thing. Let's say this is your input for now. Okay, and now you want to find how many flowers will be visible to this person whose arrival time is 2. Correct? Can I say one thing for sure, that hey, all those flowers whose start time is greater than 2 won't be visible. Yes or no? If a person visits at 2 AM and if there are some flowers whose start times are greater than 2, of course those flowers will not be visible. Do you understand the point? Right? Like this flower which bloomed at 3, it will not be visible. This flower which bloomed at 9 won't be visible, because something which blooms after 2, it will shrink also after 2. So basically this 2 will not be found in those ranges. So this is one point that I want to make, and this is again no rocket science, this is very simple. Similarly, I think I can make another point also, that flowers whose end time are smaller than 2 also won't be visible. Is it a common sense again? Yes or no? Let's say there was a flower whose duration was 0 to 1. So its end time is smaller than 2. If its end time is smaller than 2, of course its start time would have been even smaller, which means that this duration would not have included this value inside it. Correct? Now, I have given you these two hints. Can you operate on these two hints and then somehow find the answer? Faizan is saying we can store opening and closing time and sort them, and then we can implement binary search and then do something. Okay, he's quite close to the real solution. I would encourage you guys to look at it, look at what he's saying, and then check whether that idea could help or not. Yeah? See, let's understand few things. Let's say we are talking about this person. Okay? Now, If we want to know that how many flowers are there whose blooming time is smaller than or equal to 2. Why I am saying smaller than or equal to 2? Start time smaller than or equal to 2. Because I know for sure that only and only those flowers whose start time will be smaller than or equal to 2 may be visible. May be visible. Because this statement naturally implies that. Yes or no, guys? Right? Now, do you understand why I have written this line maybe? Why I have written this line maybe? Because it can happen that there is a flower whose start time is smaller than 2, but end time is also smaller than 2. Such kind of flowers will not be visible, right? That is the reason I have written this. Okay, similarly, I can draw some inferences from here. The inference is that the flowers whose end time is greater than or equal to 2, only those may be visible. Now, why I have written maybe? I think you guys can again understand, because if you take a look here, this end time is greater than equal to 2, but start time is also greater than equal to 2. So the point is that, if I somehow try to count, the number of flowers whose start time is smaller than equal to 2, and similarly if I try to count the number of flowers whose end time is greater than equal to 2, will that be helpful? Will that be helpful? Yes, in some way it will be helpful, but it will not completely give us the answer. And I think you should understand why will it not completely give us the answer, because we can quite clearly see that there will be some flowers which will not be visible also, right? Like in this category also there will be some flowers which are not visible, and in this category also there will be some flowers which are not visible. Now tell me one thing, if I simply ask you that, hey, tell me the number of flowers whose start time is smaller than equals to 2, can you tell me that thing pretty easily? The answer is yes. How? If we store these start times in a separate array and then we sort that array, then the life will be very easy. So if we have a sorted start times, how will it look like? It will look like 0, 1, 2, 3 and 9. So now you can use binary search to easily figure out that how many start times are smaller than equal to 2. It's very similar to what we did yesterday. Similarly, if you sort all the end times in a separate array, what will you get? You will get 1, 5, 6, 9, 12. And now let's say if you have to check that how many end times are smaller than equals to 2 or 4 or 10 or anything, you can do that very easily. So the first step is create a separate vector containing the start times and sort that vector. Similarly, the second step is to create a separate vector containing end times and sort that vector. After that, you can easily count for each person that how many flowers are there whose start time is smaller than equals to the arrival time, and you can also count from this array that how many flowers are there whose end time is greater than equal to the arrival time. You can do that using binary search. Now the thing is that here we will have some illegal flowers also. So how do we get rid of those illegal flowers? Let's just try to understand that first. See, when you look at this category, the flowers whose start time is smaller than equals to 2, you will get flowers like these also, whose end time is smaller than 2. And now you would want to get rid of them, right? So from this quantity, you would want to get rid of the number of flowers whose end time is strictly smaller than 2. Yes or no? Tell me. Just think, in this category only those intervals will be illegal whose end time is smaller than 2. Correct? Because if you have any other interval where end time is equal to 2 or greater than 2, then you are perfectly okay with that interval. Why? Because it is starting before or at 2 and it is ending at or beyond 2. So if I somehow subtract this thing, then the life will be super easy, correct? Now one of you has hit the nail hard, Anurag, who says intersection of both. Excellent. Very well thought. Okay, so similarly keep looking here. Now what would you want to subtract from here? Which kind of flowers should be subtracted from here? So in this case you are talking about the flowers whose end time is greater than equal to 2. Now end time here is also greater than equal to 2, but you don't want to consider such flower. Which kind of flower you don't want to consider? You don't want to consider such kind of flower whose start time is strictly greater than 2. Correct? Because if there is a flower whose start time is greater than 2, of course it will not be visible, and we all know that in this category we could have some of those, right? Is it making sense? How many of you are able to understand this point? Now tell me one very simple thing. Given that you have sorted start array and sorted end array, can you find this quantity as well as this quantity using binary search? Yes or no? Yeah, you can look at this array and check that how many flowers are there whose end time is smaller than 2. Similarly, you can look at this array and find out that how many flowers are there whose start time are greater than 2. Like 3 of them are here right now, right? Okay, if you look at this entire problem, can you look at my new screen? Is this visible? Which shows you some kind of a set. Did you study set theory in your schools or colleges? Right? Okay, this is set A, that is set B, and this is the intersection of set A and B, which is denoted by A intersection B. If I take you back to the previous screen, can I say that this thing can be thought of as set A? Number of flowers whose start time is smaller than equal to 2, I can think of it as my set A. And number of flowers whose end time is greater than or equal to 2, I can think of it as set B, right? And then we realized that we have to subtract some part, like this part has to be subtracted from A. Similarly, this part has to be subtracted from B. What is this part? This part is exactly this thing. This part is exactly this thing whose start time is smaller than equal to 2, but the end time is smaller than 2. Similarly, if you look at this thing, it denotes this section. It denotes this section, this gray part of B. Okay, so I have to get rid of this also. Now tell me one thing, when you do set A union set B, and then when you subtract both the gray areas that are lying in left and right, how many times this intersection part comes? If you look at this violet or purple part, how many times it has come when you intersect the two sets? Does it come only once or does it come twice? It comes twice, right? It's natural, no? I mean, you bring your set A and then you overlap set B on top of it. That means this area comes twice, this intersection area comes twice. And that's natural. That's very, very natural, because if you are talking about number of flowers whose start time is smaller than equal to 2, then, you know, in that case, you will get this thing. Yes or no? Because this is an interval whose start time is smaller than equal to 2. Now, this would be considered in this part also. because when you are counting number of flowers whose n time is greater than equal to 2, 6 is greater than 2. So this will also be considered. So basically the point is that this intersection part will end up appearing twice. So what we have to do is we have to divide our answer by 2. So I can say that, hey, my answer is going to be addition of this and that divided by 2. That will give us the intersection part, and that will be our true answer. Did it make some sense? How many of you could understand this part? Anything that you want me to probably talk about again, I can do that before we. Can you please divide part? Okay. Let's just think about the two sets. Forget about the question for a while, and let's just look at this problem. Let's do some set theory. You have set A and you have set B. Okay. What you have done is you have done A union B. So A union B is what we all know, right? In that this intersection area comes twice. Now from this A union B, you want to subtract this gray area, the gray area of A. Can you see the gray area of A? So let's say you subtracted that gray area 1. And now you want to subtract the gray area of B. So minus gray area of 2. So what remains? If you subtract both the gray area, this intersection part remains. But how many times it remains? 2 times, because it came with A also and B also. So that is the reason we need to divide that by 2. And if you don't understand it from here, you should be able to understand it from here, because when you are counting the number of flowers whose start time is smaller than equals to 2, then any valid interval which literally encompasses this will fall into this category. Now that valid interval will also fall inside this category, which you are calling as set B. So any valid interval will come here also and will come there also. So we need to divide by 2. Does it now make much more sense? So guys, can you correlate this thing with this diagram? Yes or no? Okay, awesome, great. So now all that's remained is to finally code it. It was again a beautiful question, isn't it? I mean, nothing very special, nothing very fancy about it. Simple binary search, and you just had to map this question to some logical end. In order to solve coding questions, you need to be good with, I would say, just even if you are very good with 10th class maths, you are mostly able to maneuver through the questions. Photonic is asking, number of flowers smaller than equals to 2 will also come in number of flowers smaller than 2. Why we subtracted? See, what you have written is not complete. When you write number of flowers smaller than equals to 2, what does it mean? What are you talking about? Are you talking about the start time smaller than equals to 2, or are you talking about the end time? Mind it, here it is start time, here it is end time. Here it is end time, here it is start time. Just see those differences. Yeah. You see that, right? See, when you talk about the number of flowers, you got it? You got it? When you talk about the number of flowers whose start time is smaller than or equal to 2, that can encompass intervals like these also, whose end time is also smaller than 2. So you want to kick them out. So this is how you kick them out, right? And the same thing you do here to kick this out, right? How many of you can code this question on your own? All that you have to do is you have to implement simple binary search, which can take 2 sorted arrays and then tells you that how many elements are smaller than equals to something, greater than equals to something, strictly smaller than something, strictly greater than something. So in the brute force you can write 4 different functions. So that is what I did to make it code it pretty quickly. So can you guys see my screen, this screen where the code resides? So I'll tell you what exactly I did here. So I created a vector for starts, a vector for ends. Now I iterated on this flowers, and then I pushed the starting times in starts and ending times in ends, and then finally I sorted both of them. So what will be the time complexity when I sort them? The time complexity will be n log n. Imagine that the size of this is n, so the time consumed in this process is n log n. Now what I am doing is I am initializing an answer vector, and then I am iterating on this people array one by one. Now what is people of I? People of I is the arrival time of ith person. So now you can see that I have written so many functions. I have written a function which is called as get smaller or equal. So what will it do is, it will look at the starts array and it will tell me that how many elements of the starts array are smaller than or equal to people I. And that was exactly what was the requirement here. We wanted to find that how many flowers are there whose start times are smaller than or equal to people I. So this line exactly denotes that. Similarly, I believe you can understand the second line also. This second line denotes this particular thing, that how many flowers are there whose end time is greater than or equal to people I. So here I am passing end time, and you can see here I am passing the end time array, and the function I am calling is greater or equal, and this is what I have passed. Similarly, I have subtracted get smaller, get greater, and I mean the get smaller is for this and the get greater is for that, and then I have gotten a value, right? So this is my value, and what I have pushed is value by 2. Why this by 2 is there, that we have already talked about. Okay, so tell me, what will be the complexity of this for loop? So let's say there are m people, so there will be m iterations, and in every iteration you are doing binary search. Binary search will take log n time, log n time, log n time, log n time. So you are doing 4 binary searches, so 4 into log n, 4 can be ignored, so it is back to log n. So the time complexity is m into log n, or n into log n you can say, because the sorting is also done here. So it's much better than the order n square complexity, and that will not give you TLE, and that way you will be able to get your job done. Now implementation of these functions is a very super easy thing to do. So this is something for which I would say, if you want to look at my code, you can look at it, alright, but this is something which, genuinely speaking, you should try it out on your own. How many of you are already a part of Renaissance? How many of you have studied or are studying DSA from Renaissance? Can you say yes? So do you believe you can write these functions whenever I ask you to do them? I mean, even if you are half asleep, can you write them easily? You should be able to, because that was the point of keeping so many hard questions in your assignments and homeworks. Okay, so ideally you should be able to do that, and implementing this is a child's play, nothing special. The real beauty lied here. This was the most important part of the code. These days we are getting really good questions in Leetcode Daily, isn't it? What do you guys say? Really interesting question. Not the kind of questions that requires you to know harder concepts, but the kind of questions that requires you to think at the level of originality, right? These are really good questions. I mean, those of you who are consistently attending to them, you will benefit a lot from it. Okay, great then. So that's it. Let's see what we get tomorrow. Just make sure before you come to the class you have given some fight to the question. That will make class much more interesting for you. Yeah. Okay, great. that's it for today. Let's see you all again tomorrow. Bye and good night.